Hi, my name is Raiden Samaru, and today I'll be presenting my final project on mobile cloud computing. The basic outline of this presentation is as follows. Start with the introduction, then go through background of mobile computing, go through the background of cloud computing, then explain a little bit about mobile cloud computing, talk about the challenges and solutions of mobile cloud computing, give some examples, and then finally conclude with my references. So, over the past decade, there's been a high demand for newer and faster network technologies. Social media and the scientific community have similar demands, which leaves many new opportunities for research. Because of these demands, new technologies are being explored, such as agile user interfaces, web services, and cloud computing. And the technology I'll be focusing on for this presentation, as far as the introduction goes, will be cloud computing. So, cloud computing has become a very attractive alternative recently because it offers many services and has many benefits. Generally speaking, cloud computing is seen as a collection of services offered over the internet to a user or business. And that's a very generic definition of cloud computing. And for now, I'd like to keep it like that until I get into some of the details later on in the presentation. These services include virtual machines, storage, custom networks, middleware, and much more. These services are offered with the promise of security, speed, reliability, and transparency. And when I say transparency, typically that refers to the ability to provide cloud services without having the user to worry about the underlying details. And that's one of the greatest strengths of cloud computing. And typically, cloud computing is seen as a collection of on-demand services. The IDC is a group that does market analysis in the area of cloud computing. So here are some interesting facts and projections they've made based on recent studies. So according to the IDC, cloud software market has reached $22.9 billion in revenue in 2011, which was a 30% growth from the previous year. IDC expects that cloud software will grow to $67.3 billion by 2016 at a compound annual growth rate of 24%. The IDC predicts that cloud computing will significantly outpace traditional software product delivery, growing about 5 times faster. And the IDC predicts that by 2016, cloud software will account for $1 of every $5 spent on software. So about 1/5 of total spending for software will be dedicated to cloud computing. This is a this illustration is a cloud computing abstract. So here you can see the various mobile and non-mobile devices sort of outside the cloud. Basically, they use resources from the cloud. Devices like your smartphone, your laptop, and then there are other devices such as your desktop computer and perhaps a terminal. So this abstract shows some of the resources within the cloud, from the different levels within the cloud, which I'll get into a little bit later on in my presentation. Um, and the reason cloud computing is actually called cloud computing was during the early 90s when the internet was still gaining structure. They would often use a picture of a cloud or a figure of a cloud to specify the internet, and so that picture of the cloud sort of became the face of cloud computing. That's why it got the name cloud computing. So we have cloud computing, and another element of networking technology in the future, in the present and the future, is mobility. So mobility is also an increasing aspect of technology. Mobile devices such as smartphones, tablets, laptops, etc., have become an integral part of society, and it's not just limited to one specific environment. Really, um, mobile devices have become such an integral part of society that you see them when you go to work, you see them at school, and of course, I'm pretty sure many of us have mobile devices at home. So it's definitely become interwoven in today's technological world. And a large part of this is due to the fact that the internet keeps these mobile devices connected with each other, um, thanks to the progression of wireless technology. According to a report by CNN Money, the number of Americans working from home has increased by 41% in the last decade. According to the Census Bureau, 13.4 million people currently work from home in the US, which is 4 million more since 1999. The number of people who work from home for at least one day a week has increased to 9.5% of all the workers in 2010, which is an increase from only 7% in 1999. 1 in 10 people working from home is 65 years or older. And basically, CNN reports that all of these increases and trends were made possible because of the invention of high-speed internet, and advances in communication technology, mobile computing being uh, one of the significant ones. So we can definitely conclude and see that mobile technology um, is a multi-billion-dollar industry that's constantly growing, on a daily basis, quite literally. Um, some of the more popular mobile devices, of course, are smartphones and tablets. Those are some of the trending devices that are a lot more popular than, let's say, laptops. Um, and it's not just limited to those. These days, you have mobile devices like even the traditional cameras have the ability to connect to the internet. Recently, there's been uh, the invention of an SD card that actually ports pictures to the internet once its capacity is full. So just things as insignificant as an SD card, a memory card, are all becoming connected to the internet thanks to wireless technology. So from this, we can gather that cloud computing offers a cluster of transparent services over the internet to users, and we can also see how mobile computing um, allows mobile devices such as smartphones and tablets to take advantage of wireless technology. So the demand for new networking technologies won't be dominated by one single form of computing, but rather it will be done by a combination of both. And this combination of cloud computing and mobile computing is known as mobile cloud computing. So the traditional model of local servers and terminals is no longer necessary. With mobile cloud computing, resources from the cloud can be accessed via the internet using mobile devices and virtualization. And virtualization is basically simulating a server and client environment over the cloud. So that eliminates the issue of having a physical location. And on the application level, software can be developed to take advantage of this cloud infrastructure. Um, Such applications include even ones that we're already using today, such as Microsoft Outlook and Google Maps, both of which can be found on multiple mobile devices, such as your phone and or tablet. Juniper Research recently did a study on mobile cloud computing, and here are some of the discoveries they made about the increase of mobile cloud computing. Mobile cloud computing subscribers will are expected to rapidly increase in the next 5 years. According to Juniper Research, mobile cloud market the market will generate an annual revenue of $9.5 billion in 2014, which is a large increase from the $400 million market it was in 2009. That's an 88% increase. Early in 2012, it was estimated that $7 billion would be generated from mobile apps alone, and is expected that that number will jump to $29.5 billion by the end of 2013. And these numbers are actually even expected to be higher um, due to the increase of mobile cloud computing. Mobile cloud computing has many benefits, but it also brings many challenges. For example, there's no standard for mobile cloud computing, and additional research is needed to solve that. A few goals of mobile cloud computing is to decrease the limits of mobile devices with the use of the cloud on a similar scale to traditional use of the cloud by computers and terminals. Another important goal is to develop mobile devices that readily take advantage of the cloud instead of adapting to the cloud on the whim. So the idea of mobility is woven into this technological era, and that can be seen with the increased production of smartphones, PDAs, and other mobile devices. Uh, Such mobile devices take advantage of wireless technology, such as Wi-Fi and ad hoc networking. This makes access to the internet easier and faster than it has ever been in the past. Cisco has a department called Cisco Visual Networking Index, which basically summarizes web traffic, mobile traffic, um, and cloud computing traffic, things of those nature. So according to Cisco Visual Networking Index, last year's mobile data traffic was nearly 12 times the size of the entire global internet in 2000. The average smartphone usage grew 81% in 2012. By the end of 2013, the number of mobile connected devices will will be said to have exceeded the number of people on Earth. And the average smartphone will generate 2.7 gigabytes of traffic per month in 2017, which is an eightfold increase over the 2012 average of 342 megabytes per month. So we can see the huge increases in the next 4 to 5 years. When it comes to mobile cloud computing, let's look at a more formal definition. So Wikipedia describes mobile computing as a form of human-computer interaction by which a computer is expected to be transported during normal usage. Through this definition, there's an emphasis on certain components, such as software, hardware, and communication. Software refers to the apps on the mobile device, the software on the mobile device. Hardware, of course, refers to the mobile device itself. And communication refers to the protocol over which the mobile device communicates with other devices and the protocol it uses to receive data. So mobile devices on the same network are able to communicate with each other, but typically this network isn't unique. Instead, uh, instead it's something like a private or public network, something like a wireless network on campus, a wireless network you would see at a coffee shop or something like that. Connection is done to typically a high bandwidth wireless network or a low bandwidth wide wireless area network. And the communication with stationary devices is also possible with the use of mobile support stations, which you should all be familiar with since we spend a large portion of class learning about mobile communication. And as you may recall, mobile support stations were an important part of that architecture. So mobile support stations are not always available. So because of this limited availability and also limits on the battery life of mobile devices, reliability becomes a challenge, one of the challenges. Outside forces can also affect the signal strength of a mobile device. This leads to issues of snooping and interference. So security can also become an issue. And signal strength is also affected by the environment, such as buildings and weather. So this illustration sort of sums up some of the things I've mentioned about mobile cloud computing. You can see in this corner there's the mobile to mobile communication. It's linked to other mobile devices that we use today, more recent things, more trending things such as phones and smartphones and tablets. I won't really touch on the social networking aspect of it. However, the demand for social networking is something that has definitely influenced the scientific community to strive for new networking technologies, hence mobile cloud computing. Snooping and interference due to the lack of signal or weak signal is an issue on the security level that still needs to be addressed and researched further. And then, of course, your mobile devices can connect to your carrier server and use cloud services that way, which we'll touch on a little bit later. So now that we've covered some of the mobile computing, I'll talk a little bit about some of the background for cloud computing. So let's look at two definitions of cloud computing. Wikipedia describes cloud computing as a delivery of computing as a service rather than a product, whereby shared resources, software, and information are provided to computers and other devices as a metered service over a network. NIST, which is the National Institute of Standards and Technology, describes cloud computing as a model for enabling convenient, on-demand network access to a shared pool of configurable computing resources. So you can see that the definition of cloud computing varies, but typically it consists of services offered to clients over a network. Typically that network would be the internet. These services offered by cloud computing include, but not necessarily limited to, software as a service, platform as a service, and infrastructure as a service. So we'll start with software as a service. Software as a service is sometimes referred to as on-demand software. This comes from the idea that software as a service is a model that allows software hosted by the cloud to be delivered to the client via an internet browser. Some popular examples are Microsoft Office 365, iCloud, and Google Apps. Next is platform as a service. This is a model that provides the client with middleware support. So it provides a computing platform, a way for clients to develop software using the provider's resources, such as their libraries and different tools they may offer. Some popular examples include Microsoft Azure, Elastic Beanstalk, which is from Amazon, and Cloud Foundry. And last but not least is the infrastructure as a service, which is a service model that provides physical resources such as computers, in this case virtual machines, and resources such as storage. Um, the host typically handles maintenance, and the client typically only pays for what they use. So, infrastructure as a service has many advantages since the client, all the client really has to do is request a certain service, a certain amount of storage, for example, and the host pretty much handles all the upkeep, any updates, any patches that maybe have to be accomplished. Some popular examples include Amazon EC2, Google Compute Engine, and HP Cloud. And this illustration shows a hierarchy of the cloud services I just explained. So basically, you can see infrastructure as a service on the bottom, you have platform as a service in the middle, and then the software as a service on top. And at the very top, there's the cloud clients, which access these services through a web browser, through an app on a mobile device, through some sort of terminal perhaps. So this is basically the structure of what the cloud has to offer. Some challenges for cloud computing include performance, because some users may experience latency based on the location and the amount of data being accessed and used. Security and privacy can also be an issue, um, since using the cloud means you're outsourcing information to the cloud. It typically means you're providing and sharing data outside of your own environment. So that has a lot to do with security and also a lot to do with privacy, since you have to put full trust in your cloud provider. Bandwidth can also be an issue, in the aspect that you can cut costs by using the cloud, but if you're using the network a lot, if you have an application that requires heavy use of the network, then you might find that costs won't be cut anymore. Instead, you might find the opposite. And also reliability can be an issue because despite the promises a cloud provider will make, there are just some forces that cannot be controlled by technology, such as weather. So a power outage, for example, can render servers and data centers useless. This was recently seen over the last year and a half, um, when Netflix had issues with Amazon's web services because of power outages across the East Coast. So software seems to be what's emphasized when it comes to mobile technology of today, but it's a combination of software and hardware that is essential for this for technology to really work. Mobile devices rely on mobile cloud computing because they have become such handheld powerhouses. Pretty much, they aren't just what they appear to be. A smartphone isn't just simply a phone anymore. It can be a camera, it can be a microphone. Um, Developers and manufacturers are incorporating touchscreens, accelerometers, different sensors, all of which are being incorporated and used to develop user-friendly experience, not just for smartphones but also other devices as well. This illustration sort of shows the structure of mobile cloud computing, shows how it works, where you can see the mobile devices on the outside, and you can see that there's a separation, so to speak, between the cloud and local servers where a mobile carrier, for example, AT&T may provide some more details on their end, and as a user, you have the option of using perhaps their cloud service or perhaps a third-party cloud service over your mobile device, your smartphone, using Wi-Fi, using ad hoc connection, um, using the internet to connect to the cloud. So the general idea is to provide cloud-based services and resources to mobile users by way of the internet. Computing power, storage, and processing are transferred to the cloud, so the requirements for an effective mobile device have been greatly reduced. Terminals are starting to reform their design to allow access to mobile devices, and this can be seen from applications like Virtualization, which offers secure options for managing mobile-based cloud computing for enterprises. Through mobile cloud computing, mobile devices can connect to a base station, such as a 4G tower, or a temporary hotspot, such as Wi-Fi, at a public location, to use cloud resources by way of the web. Also, mobile devices can gain access using proposed cloud architectures such as mobile cloud middleware, which are basically applications which allow third-party applications which allow connections to the cloud where to a device that's not necessarily made to do that. So basically a device that's non-smart. And connections follow the same principles as a computer would to connect to the cloud. So the mobile device sends a request to the cloud service via the internet. The cloud establishes a connection, and the mobile device monitors the connection until the transaction is complete. Some of the traditional challenges that mobile devices face that are reduced by using mobile cloud computing are things like the power. And battery life has always been an issue with mobile devices, since there is a direct relationship between the complexity of a program and the amount of power it requires to run successfully. So by running applications from the cloud, on the cloud, the battery life of a mobile device can be extended. Also, and one other challenge that's sort of solved is processing. So the cloud can divide more complicated apps by handling data intensive tasks and leaving simpler tasks for the mobile device. So if there's an app that requires a lot of data or a lot of computations, some of the harder complications, some of the harder tasks can be done in the cloud. And the simpler, more user-friendly tasks can be left to the mobile device. So that the user now has an application from the cloud, but all they have to worry about really is the visuals, so to speak, and all the behind-the-scenes data is done through the cloud. This is important because it frees up the processor on your mobile device, um, just to either wait for more things to be done or go ahead and handle some background processes. Another one of the challenges that mobile cloud computing can solve is storage. The cloud offers many simple and convenient solutions for storage with multiple sizes and with the ability to recover data on other devices. And we'll get into some examples shortly and see how that kind of works. So even though mobile cloud computing still has many areas to be researched and still has many challenges that need to be solved. It's still useful enough, it's still relevant enough to be used by many enterprises and their mobile counterparts. One popular example is the Apple iCloud. iCloud is Apple's cloud service for devices that run their their iOS operating system. Um, it's free for the 5 gigabyte size and can be expanded up to 10, 20, or 50 gigabytes via an annual fee. Through iCloud, users can store and recover data and apps, and data is encrypted with 128-bit AES encryption, and authentication is handled using secure tokens and a secure SSL connection. So even if a user of an Apple device uses a uh, third party application, it would still be secure due to the secure SSL connection. Another popular example of mobile cloud computing is Microsoft SkyDrive. This is a cloud-based virtual drive for Windows 7, Windows 8, Apple iOS operating system, and also Android devices. Size includes 7 gigabytes for free and can be upgraded to 20, 50, or 100 gigabytes for an annual fee. With Microsoft SkyDrive, you can view, share, upload, and sync data, and it's particularly useful on their smartphones, where you can open up a document and using Microsoft Office like you would do regularly on a computer. You can edit on your smartphone and then upload it right back into the cloud. Then when you go back to your desktop and boot up Windows 8, you can find your document in your SkyDrive edited the same way you edited, just like how you edited on your smartphone. So it's a pretty convenient option. Another popular example is Google Drive, which is a cloud-based virtual drive for Windows, iOS operating system, Chrome, and Android devices. Sizes include 5 gigabytes for free and can be upgraded to 25, 100 gigabytes, or 16 terabytes. Using Google Drive, users can view, share, upload, and sync data using your Gmail account. And Google Drive has built-in tools for editing things like Google Docs. So in conclusion, there's a need for new networking technology as demands for faster, more convenient methods increase. With the existence of powerful mobile devices and the idea of virtualization, thanks to the cloud computing infrastructure, mobile cloud computing is on the rise. Many limitations such as storage, processing, and power can be lifted. However, many challenges still remain, including areas of security, quality of communication, and many other challenges remain to be perfected. So mobile cloud computing will and is already playing a large part in the future, but further research must be redone and is required in order to create a more stable mobile cloud computing community. And that's basically my presentation. Here are my references that I've used in my paper, and I hope you enjoy the presentation. Thank you.